Come on, sound. Can someone give me a 5x5 on the chat, please, that the sound is coming through okay? Sound okay. All right, good. YouTube was bitching and moaning at me for some damn reason about the setup this time and made me re-authenticate everything. So it was a bit of a problem connecting. Okay, so this is a really wacky one. So your trigger warning is that we're going to talk about physics and weird stuff here, which is a lot of fun at one level and might be profitable. And I've got a finite time limit on this, and we're likely to be interrupted with phone calls and such, but let's get into it real quick. So I'm building a ray gun, and at the moment it's this boxy thing because I need to get in and muck about with it, so I'm not trying to make anything miniaturized. I'm just trying to make it work, right? Make it work and then make it pretty. Anyway, and so this guy comes on in, he's delivering some stuff for my office. It's all torn up and had been gutted out, and now there's insulation up there that stinks to high heaven, which is why we're actually doing this, because I can't be out there working. Anyway, though, so this kid says, hey, he wanted to know what the hell was this thing sitting in the middle of the room. And so I tried to explain it to him and stuff, and he looks at me and he says, so you're trying to build a phaser? And I had to agree that, yes, indeed, that was a very apt description of what I was attempting to craft here, right? And anyway, though, so the idea is that, so if we look at the little picture that's just directly underneath me, that's this weird little sketch I had done some time back of the guts of the ray gun at this moment. And every little bit that I've been messing about with has brought some incremental divergence into tangents that are necessary research, so I can be sure that I have a good concept of what I'm doing here. Anyway, so I don't know if we can see the cursor or not. The cursor's on the picture there, and it's a bulbous kind of thing because it turns out that shape is better than something that's cylindrical or maybe conical, a dual tetrahedral style cones joined at their base might be better, but I haven't gotten that far to investigate it. There are issues here because the bulb thing is basically the waveguide. This is for the entropy, negentropy field generation ray gun, which is, the idea is that we're going to capture some of the stuff that Cozy Rev had discovered and described, and that entropy exists in two forms, a left spin and a right spin. One is entropy that you might see as in totally disorderly, in the sense that if you had a bowl of acetone in the room with you, and it was like in the 70-degree range, it's going to evaporate off fairly quickly, and the acetone molecules will try their best to spread themselves throughout the entire space, right? And they're not even going to be particularly interested in how evenly they're spread. So that's disorderly entropy. Another form of entropy occurs, though, that most people are not aware of, and that Cozy Rev had really keyed in on here, and that is this orderly entropy. And this gets into a much larger discussion about the function of both of these fields, because they're an entropic field that spins left or it spins right, and from our perspective. And an orderly entropic field is like when salt crystals form at the edge of the ocean when the water is warm and the air conditions are right. And the waves will put disorderly molecules that contain saline up on the beach, and the saline with the entropic field that's available will organize itself into structured crystal. And so there will be more order there than had been before. And if you want to think of it in one way, the negative entropy would have been used up. And so our idea that is given to us from classical physics that the universe is going to die in a whimper of entropy as everything fades out to absolutely nothing is totally bullshit. It doesn't work that way. Entropy, as we were told in academia, is the tendency for all matter to want to dissipate to one even flatness and not be dynamic. And we know that that's not the case. There's a major flaw in the theory, which is that we should be able at this stage in the age of the universe turn Hubble or Kepler or any of these large telescopes out and about into the galaxies and look at and find solar systems in whole galaxies even that have decayed into entropic vacuums, or not vacuums, but vacuoles, enveloped, right? And we don't find them anywhere. So there's no sign of actual manifesting evidence anywhere in the universe of a state of entropy that the universe itself might be drifting towards. So this blows the hell out of the Big Bang Theory because the back end of it is open, so to speak. You know, there's no end to the universe. Now, the universe runs on what we call the little bloop theory. You can go find other interviews I've done, discussions about that. But let's get back to the entropy fields. So the idea here from Cozy Rev is that you can create an irreducible or irreversible event, okay? So that it happens and it can't be undone. So for instance, you could take salt and redissolve it in the water and that entropy is then reactivated, so to speak. But if you put acetone out into the environment in a bowl, you're not going to be able to shove those acetone atoms back into that bowl and get it into a liquid form. So in that sense, there's actually an event criteria, an aspect or an attribute of an event that it can be labeled as irreducible or irreversible. And the two are not quite the same in any event, though. So if you get such an event, and that's what we're attempting to create in our little gun here, inside our little bulbous chamber, which is actually at this point this box that's been stuffed with foam and shaped, and it's got various different insulating materials on it. And the idea is that we create one of these events, and we capture the entropic wave field that results, and then we polarize it, we magnify it, and then we shoot it out the little open end there. And ultimately, the idea is we would miniaturize this whole process to something that would be handheld and didn't need 2 car batteries to run it, which is where we're at the moment. Anyway, if we look at this, if you were to blow this image up, what you would see is that in the middle there, the idea is that we're going to have a tungsten wire. We're building ourselves an electron gun, very much like you might find in the back of one of the big old televisions that had the big tubes, right? The giant tube televisions had an electron gun that just blew out electrons in a steady stream, and it was controlled as to what happened when it ignited the phosphorus on the inside of the screen and caused the screen to glow. We don't make displays that way anymore. However, the electron gun idea is really good because once the electron has exited the electrified bit of tungsten wire, we're not going to shove that electron back into the tungsten wire, at least not without some great difficulty. So we can't return to the state of entropy that existed before shooting that electron out. And what we're doing here is that basically we've got an electron shooting off the end of a tungsten wire, a little tiny piece. It's only about 3 inches, and it's very pure. I won't go into the details of it, but it's a little short piece of tungsten wire that's electrified. It's within an insulator, and then that insulator allows it to be stuck into a metal box that's electrified in the opposite polarity. And then there's a common ground to the whole device. And the little metal box has sort of a holder in it that holds a graphite rod. The graphite rod has been drilled out such that the tungsten wire fits inside it and goes in a little over half the distance. There's some little tiny side vent holes in the graphite rod. And then there's a very small, basically needle insertion that creates a little tiny hole at the very end of the graphite rod, but there's still graphite between the exit hole, so to speak, this dimple, and the end of the emitter itself. Okay, so and you flip a switch, the DC voltage comes on in, and the wire heats up, and a stream of electrons is emitted. But the graphite is such that the graphite's absorbing most of them. There are side vents in the metal box that will catch all of the entropic releases, even on those electrons that are generated and not used, that don't exit the graphite. But basically, we're counting on 1 to 1 million. We don't know how much exactly electrons to end up shooting out of the end of the graphite. And then we have a further blockage, which is there's a slit in the metal box, so they've got to go through a single slit, and then they go out into the chamber, and it's actually, the chamber is much larger than the box, and then it goes, and then we get the magnification of the entropic effect. And indeed, if we do this right, the idea would be that we could create a phaser, because we could have our both our event and our magnification process tune that event to different types of actual physical effects out in the universe. So this is where it gets a little complicated, okay? Because I was looking at the idea of irreducible events versus irreversible events, and I come across this, I've known about him, and I knew about him in some detail, at least a lot of the claims, but then I had to, some months back, I came across this idea, and I really had to investigate it because it made a lot of sense. And I'm still of the opinion that the idea is brilliant. It does make a lot of sense, and we're about to discuss the reasons for the brilliance here, and why it all pertains to this, and why wine glasses are involved. So, but we've got to go back to, what was the name of that company? Theranos. Okay, so there's this company that had been around recently in the last, say, 15 years, I think. And the idea was, it was run by this woman, I can't think of her name. She used to wear Steve Jobs kind of sweatshirt sort of things. And she was trying to be the female CEO Steve Jobs, and she had a brilliant idea. It's absolutely brilliant, which was that, you know, from a single drop of blood, you ought to be able to extract everything you need to know about that individual's health in terms of the metrics that our current allopathic medical system uses. In other words, why draw, you know, liters of this stuff, you know, not liters, but, you know, tubes of blood, when you could do it all from a single drop of blood, if we were smart about how we did this, and she claimed to be smart about how to do this. So there's two separate instances here, and the reason I'm bringing this up will be clear in a second. So there's two parts to her story, whatever the hell her name was. Okay, was the initial idea, makes a lot of sense. Let me get that out of the way. And but the execution failed totally, completely, and it became a gigantic fraud, because she had hired all kinds of people and then started producing these kits and then sending in results, but the results were erroneous, bogus, or were being done by other laboratories using methods that were not her invention. And so her idea and its original concept was flat out brilliant, makes a lot of sense. Then she raised a lot of money, and then the company went, as they couldn't deliver on that initial promise. And her issues aside, she is a template for this guy I'm going to talk about from the 1800s. Okay, so this guy's name was John Keeley. What's his middle name? I wrote it down here. Ernest Worrell Keeley, John Ernest Worrell Keeley. He did a lot of his work just shortly, but his original insight came before the American Civil War, so before 1860. And there's, I can get into how I found some of this stuff. Really, the only way that I could have found it was because there was a happenstance here that his original insight caused this company to be formed. So here's this guy in the 1860s, and he comes up with this idea prior to the 1860s, in which he conceives of a new motive force. Now, we had steam engines at the time, we had early combustion engines, we had alcohol engines, we had the beginnings of Stirling-style hot air engines, and these kind of things, right? But John Keely came up with this idea of what we would think of as like a sustainable engine, not necessarily a perpetual motion, but something that would be so highly efficient that it would be as close as we could ever want to perpetual motion for the amount of energy we had to put into it, absent its original construction. And his idea was flat out brilliant, and he demonstrated it to people. And this was in the 1860s, I believe. They actually formed his company, which was like the Keely Motor Company. And he raised $1 million, $1 million in Civil War currency. Somebody should pop over and do an inflation calculation and see how much that is in our current money, but it's a whopping huge amount. And he did that. He raised that amount of money out of very sophisticated investors, very much like this Theranos woman. The people she was dealing with were not slouches. They were professional investors. They knew what they were doing. They supposedly were all doing all their due diligence, etc., and it went nowhere, and it bombed out. And yet, and all these people, I mean, they made the company worth $1 billion or some outrageous amount of money, and it had a bogus product. Well, Keely in his time sort of did the same thing. He raised this $1 million, a little slightly over $1 million. It was like $1,001,060 or something. And he created the Keely Motor Company. And the Keely Motor Company was formed with the express intention of doing the research in order to develop the motor from his discovery of the motive force. And then they set about, doing regular company stuff, right? He set up a lab. He got the $1 million. He lived well, but not extravagantly. And he set about doing the basic research to get this to occur. Now, let's also understand that in the 1800s, we didn't have mass communications the way we do now, so people were not on his case constantly once they bought into his company. They might not expect to hear anything back for years because they knew this was even pre-Edison, right? So it's pre-giant electrification of the country. There was not even the idea of mass anything, but they knew that they were onto something because this guy could demonstrate this motive force at work and had done so for the investors, the original group of investors that allowed him to parlay it out, spend the money to raise the further capital that netted him over $1 million. And these were very sophisticated individuals at his time, and his presentation made so much sense that I'm convinced that he was aware that he'd fundamentally discovered a basic operational physics principle. This fellow is not an academic. I think he was maybe a machinist at one point in his life, but beyond that, I hadn't investigated his previous history prior to the Keely Motor Company being formed, because I was interested in how he made his inventions work relative to the new motive force, because I wanted to use that motive force inside my phaser, right? Because it offers some serious improvements over having to electrify tungsten wire to a high degree. And this motive force is, it could be described as frequency modulation, and it's frequency modulation of reality. So basically, this is the fundamental idea here. Let me suit back up and get in on this. Okay, so if we look at the little charts or the little graphics here, off to the side of me, you see that we've got a structure of lithium hydride, and it's a crystal. And that this is the idea currently of how academics think that reality organizes itself, and this is a artistic graphic impression of that reality. And the little white areas there are the lithium. The little purple pinkish kind of things are the hydrogen. And they all sort of all touch and they form a collection there. That's really not how it actually happens. What they're actually showing you here are what are called the van der Waals spheres. And so the white spheres represent represent a rigid sphere around the electron moving around a lithium ion, okay, or a lithium atom. And so the white thing is a theoretical maximal size, maximal volume for that lithium atom. Same thing with the purple for hydrogen. And and they actually show these things touching. Now, there's two components here. This is where we start getting into the real deep stuff, okay? Because we got to go into quantum mechanics to understand what it is that Keeley had stumbled onto. So atoms don't really ever touch each other. Even the chemists that maintain that there's an atomic overlap in chemical reactions, I don't think they really understand what's going on. And they're citing evidence that can be interpreted in another way. So if we look at the little chart down at the bottom here, it's a poor attempt to show you this lattice structure with the little purple dots being atoms and the dashed and solid blue lines between them being these lines of force that are the attractive lines, okay, or the connection lines that would hold the crystal together. So we can think of these lines between the atoms as being the points in this crystalline structure where they theoretically join. So there's some attractive force there. And we know this is the case because all of our atoms don't go into total dissolution and fly off into the universe, and we hold ourselves discretely, as does all the stuff that we make. And it doesn't dissolve, right? And so if we look at a lot of the work. All right, so let me finish with Keeley really quick. So Keeley came up with this idea that he used to demonstrate to his investors, and I found some memorandum, not really memorandum, more like notes, as to a Keeley presentation before he had his lab. So while he was attempting to raise that initial set of money. And what he would do is he would go and present his audience of investors with a very simple explanation and demonstration, very simple demonstration, and a subsequent explanation, and an imagination of his, a vision about how to exploit it. And what he would do is set a fine crystal wine glass in the middle of a table, and he had a violinist over there go get the note on it, and the wine glass starts shaking and pop, breaks open. And so he shattered wine glasses in order to raise $1 million. And that's where the profit part comes in. And it was probably fun at that stage. I've done a lot of that since, and now I'm not allowed to break glass anymore because I've learned what I need to, and I can't do it just because it's fun, right? But these days, we don't need a violinist. You can get frequency tone kind of things, which I could have demonstrated if I'd been able to set up the office here and it wasn't so stinky. We'll get the sheetrock in next week, and that should seal it up, and over the course of a week and a half, seal it up, and off we go. And in the meantime, I've got the greenhouse I've got to start fitting out now that it's almost done. Anyway, though, so Keeley would raise money breaking wine glasses, and he raised $1 million, which might be the equivalent of 10 million now or whatever. In any event, so what he said was that the wine glass was, this is long before people really had a generalized discussion around atomic theory or any of this sort of thing. So this was, everybody knew at some level that it was a vibration, sympathetic vibration, that was causing the glass to first vibrate and then to break, then to shatter. But no one really could discuss the how of it, okay? And what it all meant. And so Keeley had sort of a half-assed theory as to what was happening, and was able to convince people that he could build an engine around his theory and the demonstrable effect of being able to cause spooky action at a distance with a violin. And he eventually got to the point where he was using very much more sophisticated demonstrations to raise even further money. But that's when it started shading into fraud. So he was a deliberate fraud after a point, and I think that point came fairly rapid to him once he'd gotten his million, or a big portion of it, and set up his lab. I think he realized at that stage he could not figure out what this force was and how to extract this force into basically turning something, which is how we get mechanical force out of everything. And so at that point, he started realizing that, well, his goal was to keep raising money, not ever deliver a product. And he got he made some really crafty, fraudulent machines that he claimed were operating under the principles that he discovered and were part of his experimental process. And they worked when he was present and in his various studios and stuff. And only 2 demonstrations were done outside of his lab. And one of those failed. But it turns out that he'd rigged his lab entirely surreptitiously with compressed air and other parts of a fraud, moving air from the 3rd floor or up to the 3rd floor from the basement, that sort of thing, in order to reduce the sound of the compressed air, and actually was doing things to cover it all up. Hidden channels for the piping and all of this sort of thing. So at the stage that he was doing the demonstration, some number of years on into this project, he was a deliberate, fully practicing fraud. And he maintained that ability for 26 years. Took I think, until his death, basically, before people really found him out. And there were people that at the time called him fraud and so on, and tried to examine his machines and so on. And none of his machines have ever been operated after his death. And his offices and his labs were looked at, and they found all this fraudulent stuff. Now, as a slight side there's 2 other guys at that same time in history, one of whom was a German, or actually 2 German brothers, and this Russian guy. And the Russian guy powered a train with a device that could not have been powered by compressed air, the way that Keely's stuff was, and it was theoretically propelled by a sympathetic vibration. And this Russian guy was, at the time, in written communication with Keely. And there was some mutual justification of their positions being discussed in old Scientific American articles, and not them, but it was maybe it was the San Francisco Journal. Anyway, because there were a lot of investors from San Francisco put their money into Keely's stuff. Bear in mind that this had been followed the gold rush in California in the period of 1840s. So there's a lot of money sloshing around, and it was a time of malinvestment in general. It was very much, and it was actually part of a tech boom. So Keely rode a very giant wave. Okay, he was very much like this woman who ran Theranos in the midst of another tech boom. And it was also a fraud. So there were a lot of the same sorts of circumstances that caused these 2 things to be very similar. And so here's Keely, and he's producing fraudulent machines, but his all the rest of the time that he was not actually fiddling with making the frauds and the bogus demonstrations, he was pursuing his basic idea. But they didn't have the servo motors, the digital aids that we have now. And so and even the conceptual aids around what is occurring. And so he was never able to really manifest the potential that's in there. And basically the idea is, let's grab the free energy that comes from stringing the violin strings here and causing the wine glass to blow a big chunk of itself out of the rest of the structure. Because, it takes considerable thunking to get that glass to break otherwise, yet here you can do it with just this little string motion. And so it set him off on a particular thread of inquiry and experimentation. Now, the reason I want to use it is because the basic core of what Keely had ascertained and some of the writings he had done before he, as I say, in the early years, probably the first 5 years, some of the notes he'd made lead me to a certain line of understanding that is validated by quantum physics today and quantum mechanics. And yet it's hugely overlooked, in my opinion. So I'm going to jump us over to another screen here. And I've got to do this, as I say, I'm expecting a phone call. I'm going to get interrupted. And we're running up against a tummy clock. I'm going to have to go get lunch at some point. So here's the conundrum. All right, quantum physics says that the van der Waals sphere is of the finite limit of an atom is 100% empty. That if you go to look for an atom, for a lithium atom or a carbon atom or any of these other atoms, let's choose carbon. It's going to become useful later on to understand carbon. Carbon's got 6 electrons in 2 electron shells, 4 in one, 2 in another. It's got 6 neutrons and 6 protons. And carbon is a very interesting substance for our experimentation because of the electron shells. But its sphere is of a certain size. I think they're measured in picometers, which is a millionth part of a meter. Anyway, so the sphere around a carbon atom, according to quantum physics, is empty, 100% empty when we're not looking at it. And when we go to look at it, we can pick a spot within these electron shells, which are mental concepts, bear in mind, okay? They're not actually rings, and the electrons are known to jump from shell to shell and do other strange behaviors that are not usually discussed by academics. And so it's only a concept, it's not an actuality. But our concept is that there's 4 electrons and then 2 electrons in the inner and outer shells of carbon. And if we go and look at them, at any given time, we can sort of like jab at a level of potential within that atom, and theoretically we could find an electron where we jab 1 out of 3 times. Okay, so at any given moment, there's 3 places that have a potential for that electron to be, and if we're really fast, we might be able to jab our finger or our little tiny device and spear that little electron. So basically, electrons don't exist. They're not hard. They're more of a wave form than they are a particle. And the same thing is true of the nucleus. Now, bear in mind, the nucleus, which I don't have a picture of, is a bunch of hard little nodules, you might say, and they're all clumped together, and there are 6 protons and 6 neutrons, and they're sort of gathered together in groups of 2s around in a semi-spherical fashion. They don't line up as a ladder, they don't bust out into any other kind of a grid pattern or something like this. They're all clumped together. This is very key. The reason that this is very key is because if you notice the little drawing that's up over my head, we have this thing called 1 point. And this is what Keeley discovered, all right? And this is, as I say, this is atomic theory. This is before he became a fraud, and he wrote for about 4 or 5 years. He wrote a number of notes about the idea of what occurs when the wine glass shatters. And it's a very valid idea, okay? And the idea is that what's actually happening is that the 1 point here is being moved. And so the 1 point is the point around which the electrons and the nucleus spin. So it's a point with no mass. He's writing all this stuff down, and I can validate that this is how quantum physics thinks about these things today, and that it's a point with no mass. It's the point around which mass revolves, but there's no mass in that point itself. And so it's part of the nature of an atom, and the nature of all matter is that at the center of every one of these particles is the point around which it revolves, around which it spins. Again, these are concepts, so we don't want to get too hung up in them, but they do become useful once you grasp a certain level of understanding here. And so if we go over to the other little illustration here, you see that we've got a description of the carbon atom with the little nucleus of blue and orange dots there. I don't think it's carbon. I think that I can't see too well here at the moment, but but we've got 3 electron shells there. And these electron shells are, again, figments of our imagination that are used for calculations for trying to get us to the point where we could determine where an electron is, if it actually really existed. But once again, it doesn't matter about the concept, and it doesn't really matter about its manifestation as physical reality here at the moment. What we want to think about is this idea of 1 point. The 1 point, the central point, the atomic center around which the nucleus revolves, but also around which, theoretically, the electrons also revolve. And so this is all theoretical from a quantum viewpoint because atoms are both a wave and a particle. And if you want them to be a particle, you can go and look at them as a particle and you'll see them that way. But if you really want to just leave it alone, you're going to see them as a wave. And so up at the top here, the screen, the little one that's a little bit more organized, says atom visualized as the nexus of overlapping energy pulse lines. So this is one of the difficult sections of thinking about this that we have to go into. We've got to step outside of the very crude understanding that quantum mechanics has, however sophisticated it is, and go to the woo-woo understanding, which is that everything is energy and that the atom does not exist ever as a particle, and that that's only in our minds, and that everything is basically fields or waves in our reality, and that these fields and waves are created from a pulse of energy that goes 22 trillion times a second, as everybody's obviously tired of hearing me say, followed by a void of 22 trillion times a second, so that we get this like ability to move because we're created and destroyed, because as the pulse goes through that atom, it recreates it in a 22 trillionth of a second, and then it destroys it in a 22 trillionth of a second, and this is so damn fast. We'll never ever be able to make a device that will be able to see this, and that's actually part of Heisenberg's principle of uncertainty. If you get down into the two-slit experiment, he was also of that opinion that there are limits in nature that are going to prevent us from ever getting down to that level of examination. But getting back up here, it shows you basically what's going on is that the pulse travels all through the known universe and recreates the known universe 22 trillion times a second, and when it does, it's overlapping itself, and when it overlaps itself to a certain sufficiency of complexity, you get get a hydrogen atom. More complexity, you get carbon. More complexity, you get oxygen. Yet more complexity, you get uranium. And that consciousness glues all this together into the material world that we see through our appreciation of consciousness coming in through our sensory apparatus. And yes, it's existent in our head, but there's a basic substrate from which we're interpreting signals that create the image of reality in our brain. So the basic substrate, oxygen, et cetera, as we've labeled all of these manifestations of the very complex wave, does exist. And so this energy wave creates a single molecule or single atom sort of in this little bubble thing that we're showing up there. And it's doing that continuously, constantly. It's an incredible kind of operation. And they do exist. And because we have particular concepts, we can actually cause motive force and things to exist by very crude fashion at the moment, right? We've got chunks of wood we burn, we heat up water, water gets really hot, it produces steam, we cause the steam to make shafts turn, which turn wheels, and we sit on our ass on the top of the things and we go. We've got something even more crude, which is the destruction of the electrical bonds inside uranium that separate out uranium into other elements by destroying the electrical cohesion of the bonds within the nucleus, and we get what we call nuclear power, but really it's electrical degradation power. When you rip them apart, electricity is released in vast quantities, which causes the water to heat up, which causes the wheels to turn, because basically it's still steam. Now, one can see from this idea of the electrons, and I'm going to go back to the other one here in a second, for just a second. If we look at the space-filling model of the lithium hydride, we see that you could look at this as points, and I think it was in like the early 1800s actually, like maybe 1830s to 1850s, that we started getting into really general atomic theory, and atoms were considered more than just a hypothetical point. But in any event, so if you looked at this, you could look at it as points that form through their interconnections, a lattice work. And this is very important, okay, because what's going on is that I think I've discovered an explanation for sympathetic vibration that makes a lot of sense and provides some potential for piggybacking off that understanding to actually create the kinds of motors that Keeley wanted to do, and Schauberger, Victor Schauberger, this guy in World War II, actually created. Which they're called implosion engines. And they are, under my understanding here, what I'm going to try and communicate is also the reason that we get such things as cold fusion, and which is also known as sonoluminescence, the creation of light in the midst of a water by collapsing a bubble. Okay, so, and that gets down to the nature of water, but we're not going to go there today. We're not going to go too deep into a lot of this. We're just going to get through some of this until we have an understanding of why these damn wine glasses break. Okay, so let's go back. There's anything in there. Okay, so basically, we're dealing with a lattice even the lattice itself is formed of all of the energy waves crossing and interconnecting and all of that. So it's all at that level. It's all energy. And so here we go over to the understanding of what's actually going on, okay, and how the wine glass breaks. And then I'll get into formulas about how we can make this into something that's viable and useful to us. All right, so we need to understand that there are forces that bind the protons and the neutrons in this little cluster. And then there's forces that keep the electrons, theoretically, spinning at a particular space distance away from that cluster. And then there's also another level of force that binds atoms together. And we find some atoms are very reactive and bind very strongly, like hydrogen, carbon, and oxygen, among others. We find some atoms that don't really want to bind with other stuff, like mercury, right? Mercury would much prefer to just be in itself and not try and bind to other stuff, but it's amenable to doing it if we wanted to do it. But there are, I mean, if you start looking through the periodic table of elements, you find that the relationship that any given element has to other elements is going to be varied. So they don't all bind at the same level. They don't all have the same level of strength in those bonds, and it becomes very complex to consider. However, if we eliminate the attributes of the strength of the bond and just consider the bond itself for a minute as every bit as real as the atom itself. So in other words, we know from our previous scenes here on this little thing that the atoms don't really exist. They're mainly space. It's all theoretical. The electrons are just, when we get down into it, you can't really ever see an electron. You can't find them, this sort of thing. And that's why we have all of these whack jobs over at CERN trying to smash particles together to learn more about them through inference, because they can't actually see them and poke them and get a response. Because they're a theoretical concept. That being the case, there's no reason that we can't also apply that same level of reality to the bonds between atoms. And thus we get to the idea that the lattice work, those connections between atoms, are as integral to our understanding of energy, the process of atomic theory, etc., and every bit as real in the pulse sense, because the pulse has to create that attractive force that binds those two atoms together so that my nose doesn't fall off, right? That kind of thing. And because of that, the combined forces of attraction and repulsion, because like in a magnet, you get repulsive forces as well, demonstrable repulsive forces. And so these are working at an atomic or quantum level as well. But because of that, if we stop looking at the atoms themselves as a thing and look instead at the relationships of what were involved here, we can come to certain conclusions. Now, some of the conclusions that we can make, just using a wine glass as our example, and we'll actually get to one in a second, I've sort of mapped out here. We need to preface this and say that I'm with Buckminster Fuller. There are no cubes in reality. Everything is based off a tetrahedron. So that's 4 points that are joined in a three-sided pyramid with a three-sided base, triangular base. And so a tetrahedron is the base form of all matter, including cubes. And cubes are simply two tetrahedrons at opposite polar ends joined together. And it forms a cube, and they're very stable. Tetrahedron is the most stable shape, bar none, in this material. And so tetrahedrons are at the core of everything. And what we see in this little graphic here is a crude red tetrahedron I tried to draw, and then purple dots representing atoms. And the tetrahedron is formed by these atoms, and is actually the relationship. It's the bindings, the attractive repulsive force that is held that creates those. Hang on a second. than the atoms. Okay, so all right, sorry about that. Back again. Okay. Sorry about that. Okay, so I got to back up a minute. All right. So the drawing that we've got there shows a crude representation of a tetrahedron in red, with the purple dots representing the atoms that are involved in a larger structure. This is a group of 4 atoms that are joined. And what's important here is that we note that the tetrahedron itself is formed of the relationship of the atoms, not the individual atoms. Okay, so the red lines represent that part of the pulse that is involved in forming the relationship that actually manifests between those atoms. And so these atoms might be carbon. And they're going to be in a tetrahedral shape. The whole universe is in a tetrahedral shape. Down at its core, this was an observation from Buckminster Fuller that I'm quite in agreement with, that it's a tetrahedrons all the way down. It's the most stable shape. It's a 3-sided pyramid involving 4 points and a 3-sided base. Now, we're looking at carbon atoms that have arranged themselves here in this tetrahedron. And that these carbon atoms could be in my beard hairs, they could be in a lump of coal, or they could be in a diamond. We can't tell. But what's important here is that the relationship between these atoms defines which of those allotropes we're looking at. You know, carbon in flesh, carbon concentrated in coal, or carbon concentrated in diamond. It's all the same carbon atom. It's just different relationship with the other atoms around it that cause that those different aspects to be visible and manifesting. So the relationships between the atoms are equally important, if not more important, than the understanding of the atoms themselves. And that the lattice work that defines matter is as important as the individual points within that matter that we call atoms. Now, the D here represents what we could think of as like the defined, natural, organic, steady state distance between the 2 carbon atoms in a lump of coal. And the D prime off to the side there represents the distance at which we're going to vibrate that lump of coal by strumming on our violin string once we've discovered what the frequency that coal vibrates at, right? And all atoms and everything are already vibrating. They're already vibrating continuously. All of universe is vibrating continuously. So vibration and inducing vibration and even sympathetic vibration is just part of the nature of universe that we can harmonize with and suck power from, basically. Free energy. All right, so now D prime represents an interesting point because it represents the point of no return. If we move our carbon atoms beyond the D prime level, through sympathetic vibration, then they break up. The lattice work is destroyed because it's gone beyond the point of stability. And this is what Keeley had glommed onto in terms of his idea, that if we could vibrate atoms, we needn't destroy them like we do in our nuclear reactions, right? That where the electricity is separated and the atom becomes something else. We don't have to do that in order to get energy out of them. That we can actually just, if we were able to do it, if we had the mechanisms to do it, we could take any atoms basically and move them to the point by shifting their one point around which they revolve, move them to a point of instability. So we could take them out all the way out to the end of that. We could take carbon, for instance, in coal. And we can maybe take it all the way out to the end of that D prime point right there, and that might be our point of instability, beyond which the carbon atoms would fly apart and separate into the individual atoms. But short of that, they would be in a state of still material. They'd still be solid, so to speak, but they'd be highly agitated. And so maybe that lump of coal might glow and even burst into flame. I don't know what would happen to it, but in a diamond, it might just simply, or some other crystal that's a lot more rigid, if you could do the same thing, take them to that point of instability, then it might sit there and just beam out all kinds of energy at you as that instability manifests. And we know that this instability manifests in reality because we have this situation with the wine glass. And we'll go back to the other chart in a minute here. And so this is a side view of a wine glass that I've done here. And we know that these things break. You've seen it happen. You can get on YouTube. You can even see videos of people doing it with their voice, with all different kinds of things. And we know, for instance, that it's not air. right? It's not the air wave itself going through that, so we don't create a force in the air wave where the pressure of the air is in any way involved. In fact, let's discuss waves for a second. In a tsunami or any other wave in the ocean, but specifically a tsunami because everybody understands what they are, the water that's involved in when the tsunami starts doesn't travel to the end of the tsunami. Those molecules of water that wave goes through basically stay stationary. That is to say, they stay in a more or less fixed position. But what they do is that they move up and down, back and forth, so vertically and horizontally, and forth and back relative to their initial starting point. And they do so within a little tiny space, because that little tiny space is represented by the spheres, the van der Waals spheres, the theoretical maximum point of the atoms involved, transmitting that force, going over and touching the next atom, and the force goes through it all. But so each atom in the water molecule individually gets all excited and then calms down as the tsunami goes through it. That's actually what happens when we talk. That's what happens when we sing. So you don't have arias sung by opera singers that blast out air to the point where you can feel it on your head, right? Even though these people have powerful lungs and stuff, they're not trying to blow air out. They're trying to create a vibration that goes through the air. And that vibration moves the air the same way water moves in a tsunami. So an opera singer is an air tsunami. And the air molecules move back and forth, up and down, side to side, and they do all three motions all at once, and the force is transmitted through them. So in that sense, you could look at the motion of force as being seen or visible as it travels through the molecules. But the force itself is not molecular. It's not solid. I mean, it's even less solid than our understanding of atoms, right? Because we can sort of point to a potential where we could see an electron, and we judge those spots by potentiality. But to try and judge the point of a force, the most we can do is to represent it in a two-dimensional graph, like you see down at the bottom here with the frequency divided by 2, the little sine wave thing, and make guesses about it. But we can't examine the force wave itself any more than we can actually really find that electron when we go looking for it. Anyway, so here we're looking at a wine glass, and we see that it tapers on its side. This is a cross section. And this is what Keeley would demonstrate. And he was able to demonstrate it with crystal glasses, all different kinds of glasses. And he did it with spheres even, blown glass spheres. I guess those were quite dramatic in how they exploded. And that's why he went to them in the end. But what we're looking at here is you see the little arrow pointing into the side of the glass. If I sit with a glass there and I'm actually running my little Arduino with its little frequency frequency generator, and pumping it out through some speakers, then I can tune that frequency to the point where the whole glass starts to vibrate and might even jump around on the table a little bit. And that frequency becomes more concentrated, more specific, and you'll see the shaking go up from the base up through the glass and then going up through the sidewalls of the glass. And of course, all this happens very fast, and then it blows out the sidewall of the glass. It does so when that frequency, when it's the half of the frequency reaches a particular width of that glass relative to that frequency. And the reason that it occurs is that frequency is causing those molecules within the sidewall of that glass to move back and forth, up and down, and horizontally, right? So all of those molecules are moving in 3 dimensions, very much like water molecules in a tsunami. The force is transmitting its way through those molecules. Now, what happens to the poor glass is it's a very rigid structure. It's very crystalline in nature. The molecules get to shifting back and forth like in D prime, and they go beyond the D prime point, so they get into a point of no longer stable matter, and they shear off and explode. And the amount of force that comes out of that explosion in the wine glass can be quite considerable, especially relative to the strumming of the violin force or the amount of frequency that you have to generate in order to get it to occur. And so there seemingly is a net gain in force produced in this experiment over force input to cause the results of the experiment. Anyway, our formula there is that the frequency divided by 2. So basically what you're looking at is when the frequency gets down to where it's ever so slightly wider than the glass at that particular point, then it's causing those molecules to simultaneously try and split themselves, vibrating this way, that way, up, down, back, and forth, and all of them doing it at the same time in this particular expanded fashion. And that is beyond the predefined stable manifestation limits of that lattice work. And so the D represents the distance involved relative to the tetrahedral molecules as seen from our previous chart here. And the L is the sum of all of the binding limits on that aggregation of molecules, whatever it might be. Now, glass is interesting because it's a finite number of molecules, primarily silica, and so it's a little bit, and in fact, you do these experiments with very pure glass, so you get something that's almost monomolecular, and it's a known level of rigidity, but the glass is interesting because it can be, the frequencies can be found in a fairly pure fashion. If glass, so if it's not like the same as like a fired pot, like a terracotta pot, the reason that you couldn't do the same thing to a terracotta pot easily, you could do it. You could actually set up a terracotta pot and determine the frequencies, but you have to do the frequencies of the aggregate mass. So you'd have to find out, have to look at all the atoms, see what the limit distance is on the various atoms that are in the terracotta pot that is basically mud. So you got to get sand, you got to get some metals, you got to get some ash, you're going to get all different kinds of stuff in there. And so you'd have to have the combined limits on that in order to get a handle on how to make it fly apart with a frequency generator. And so it would be a very much a different process because it would be a chord that you would have to, most of these are chords, by the way, anyway, even with glass. It's very rarely a pure note. But anyway, back to the terracotta for a second. So if you're going to do a terracotta pot, you'd have to have some way to get the ascertain the limits collectively, sum them all up, and then get a frequency out of that, or to attack all of the various different limits from various different frequencies simultaneously, which would be the chord approach. Then there's one other thing that's an issue here, and that's the little red dot that we see, or red circles that we see down there. That's like a theoretical top view of looking down on this glass and seeing the edges of the top, and then seeing it spread out a little bit. And you'll notice that what it's really attempting to show is that there's likely that the shape of the glass itself contributes to both the frequency involved and the nature of the disruption. Okay, so experimentally, what happens is that when the glasses break, they break in an outward fashion. So part of the glass blows itself out onto the table when this occurs. And you're left with a sort of like a crater's edge on the glass that's outward facing. And so this is due to the constriction of the lattice work being tighter in the central core of the glass and becoming slightly less tight as that glass becomes wider and fills out space, so to speak. And so when the glass vibrates and is disrupted, the molecules that are on the outside edge of the glass their lattice work is ever so slightly different in terms of its density than the molecules on the inside of the glass. And it is the expansion of those molecules on the inside of the glass that cause the molecules on the outside of the glass to fail first because of the pressure against them. And this is dictated by the shape. We know this because what we did was got some glass guys that I know that are actually seriously involved in this, to be able to produce a sheet of a known thickness. And then I was able to find wine glasses, champagne glasses, or flutes they're called, and blew the hell out of a lot of those. And I was able to get a particular thickness of glass that was the same thickness and the same purity of the glass as in the champagne flutes, and only it was a sheet. It was just the same thickness all the way across. It was a 12 by 12 sheet. We ended up cutting it ultimately later on into 6 by 6 chunks. But it doesn't break at the same frequency. So the shape of the glass participates in this, because the same frequency that would consistently blow out the champagne flutes to the point where it became quite annoying and was starting to fill up my recycle bin wouldn't scratch the surface of this single sheet. Now, it was possible to get that single sheet to shatter, but it was an entirely different frequency. And so my supposition is that in this case, because of the similarity of the materials and all of this and the thickness and all of that, I'm assuming that the logical conclusion is that the shape is actually impacting it. However, the other part of it is that the frequency formula is valid. So, and it works on the single sheet as well. It's just a different frequency than is effective as on the glass. Okay, so now basically, let's go back. Let's go back here for a second. So basically what we're doing is that we've been manipulating the center point of and able to take it out to the D and get glass to shatter by going one little tiny bit beyond the point of stability that's referenced by the D prime. And this is the thing that results in the crack here at this particular point that occurs, and it's because we reach the limit of the vibratory capacity of those molecules at that particular point. It's not atoms, because it's not monoatomic. It's a molecule, sand and little bits of metal and this kind of thing. Okay, now also bear in mind most elements in our universe are metals. There's a couple of fluids, like mercury and bromine. They're even metals, really, at that level. But we have a few non-metallic elements, but very little of them. And so my examination of the periodic table relative to this kind of an understanding is leading me to believe that the ability to manipulate matter at an atomic level with frequency will be very good because of the resonance capacity of metals, basically. Now, we have to understand, and go back to our other picture here, that we're really looking at all of universe, like up in the top corner there, as being the formation of matter-like substance or matter-like illusion that comes from the shifting of energy. And so the shifting of the energy here, or the recreation of the pulse, is creating our reality. But here's the interesting part of this. If we wanted to disrupt matter, as I do with my little ray gun, then the central easiest way to do it is to actually move that point of non-mass and let the molecule and the pulse catch up, so to speak. I mean, I don't want to get too far down into quantum physics and the formulas and crud, but it's possible that Keely's understanding, which, okay, now something that's really interesting here, a lot of Tesla aficionados will know this, that Tesla was all hung up on this idea of 3, 6, and 9. And he was saying that 3, 6, and 9 is the secret to the universe, and that should an individual understand the 3, 6, and 9, then one would be able to basically be a master of universe, be able to control things. Well, the 3, 6, and 9 came from Keely, came from Keely's work and 2 articles that were written, one after the Civil War and one prior that was, he didn't write it, or Keely was not particularly, as far as I know, other than his initial notes, he never published, was not a big proponent of letting people understand what he was doing, other than his original investors, and then he ran a company just as it was standard practice in the way he did things there. And they expected perhaps, he actually at one point told them that, it might be 10 years before they had a practical engine that could go to production. And so people were content. Time frames were different. They weren't driven by instant communication, etc. So the whole stretched out part of it was a different aspect of it entirely. But Keely's whole understanding of it was conceptualized in his notes and then through those people that reported on him. And at one point, even in his fraudulent years, he had a reporter that lived with him or stayed at his house and saw him do experiments and things. And they saw the big pile of cast-off old equipment. But his idea that you could move that one point by sympathetic vibration, and we demonstrate that in breaking glass, or even moving other materials with sound, I think is extremely solid. You know, pun intended, right? and what we're actually having to do at this stage, which I don't think we can get into today. No, it's getting late. Can't get into that today. But what we're attempting to do is to take a formulistic approach and get to where the 1 point, we can have math around it. Okay, so that we could analyze it to the point where we might be able to predetermine frequency of some matter using some maybe highly sophisticated smart tuning fork or something, and then go and generate that force that would then cause that matter to do what we want. And we would do so not by attempting to hassle the atoms themselves, but rather we would do it by messing about with the bindings, the molecular and atomic interconnection, repulsive and attraction force. And this is likely how we had sound as a motive force for, theoretically, for, you know, the giant megalith constructions and that sort of thing. But we know that there are interesting things that can be done with sound just by cymatics, which is the demonstration of complex geometric shapes as a result of changing the frequency of sound to which these things are subjected. I'm going to have to go, and I've actually got to go and do chores and get food and this kind of thing. I think I pretty much covered all of it up for part 1, and why and how to do wine glass shattering, right? It's actually real simple. Get an Arduino and a bunch of wine glasses in an area where your wife isn't going to bitch too much, and with a frequency generator and a little tiny speaker. And you can blast the hell out of them, and it's kind of fun. And it can be quite profitable once we figure out how to apply that same concept as Keeley tried and as Tesla discovered. Now, Tesla actually took Keeley's 3, 6, and 9, which Keeley got, I suspect, from a secret society connection that he had briefly in his late teens and 20s. I suspect that's where he got the 3, 6, and the 9. And then he later on understood that what he was attempting to do. Now, you can think of this as being chord factors, okay? So if you're a musician, you would understand that we're talking about thirds. And so, you know, so we're talking about the manipulation of reality, and the 3, 6, and the 9 are the descriptors that are applied to that manipulation of frequency such that various different kinds of manifestation could occur. And so in that sense, it was a fairly occulted or hidden understanding that he came to. And then he went on to demonstrate it, raised all kinds of money, and then decided, you know, I mean, he probably ran into hard walls real quick because they didn't even have, you know, oscilloscopes or digital analyses or these kind of things. And so he ran to the limit of the technology real quick and then just decided to fake it from that point until he died. And he was very successful at doing so. So he was better at it than the woman from Theranos because she crapped out on non-delivery, and he kept going all the way through until he died on non-delivery and still kept the money coming in and had people believing in his products and so on. His basic understanding is quite sound. His machines were not ever able to operate and could only operate in his presence because they were frauds, and he knew the secret codes and manipulations to doing so. But that doesn't stop the understanding about this 1 point and the ability to shift that via sympathetic resonance as being a valid aspect of quantum physics. Then if you get into people like Feynman and his understanding in his lectures on quantum physics, you see that indeed they're describing a lot of the same kind of things that Keeley actually tried to engineer. And we now have a larger atomic theory, more understanding, and so perhaps we can actually make sympathetic vibration physics function, whereas Keeley could not. And just as we know someday in the future, there's going to be somebody that can take a single drop of your blood and, do all the analysis that they need to, the way that Theranos could not in this time, simply because of the limitation of the technology. But we got to start somewhere with our understanding and move forward from there. Let me see real quick. I've had problems with YouTube and this sort of thing, so let's see. Questions? No, Feynman was not a loon. Well, Feynman was indeed a loon. You're talking L-U-N-E is is the moon. If you're talking about an L-O-O-N, as in the wacky birds that fly around, he was not that. Feynman was quite solid in his understanding, to the limit that that understanding could be expressed within the academic framework that he lived in. I'm free, right? I don't have an academic framework. No one's going to hassle me about my reputation or life's work or any of that kind of shit based over my understanding of physics and expression of it in a woo-woo fashion around this idea that we're all energy. It's quite fascinating if you look at certain things, right? So for instance, real quick here, let's go through a couple of them. Hot water freezes faster than cold water. The reason that this occurs is because the hot water molecules are in a higher state of vibration when you begin that freezing process. Thus, it's easier to change their vibration to the liberation of energy as opposed to the acquisition of energy, because the vibration is already moving. And just like in Aikido, if someone's running to attack me, that's the very best situation I've got, because if they're in motion, it's ever so much easier for me to flip their body around because the level of inertia is gone. And so inertia actually becomes an aspect of quantum physics, and we'll be bringing back in certain Newtonian concepts as we get into our quantum physics interaction trying to build the ray gun here, right? Bear in mind, this is all aimed at a very specific practical, well, I don't know how practical, but a fun project, and maybe even profitable, I don't know what it's going to do once I've got those fields magnified, so I'm really interested to see. Let's see, I think we've covered everything in my notes. Incrementally smaller amounts of resonance are required once you get the molecules moving. So it's actually easier to get a champagne glass to shatter. You can shatter it in less time if you'll provide a base frequency and then hit it with the frequency that we already knew because of experimentation caused it to break. So in experimentation, I've got a couple of these flutes left. Got them off Amazon, and it's messy. You can't be blowing up your kitchenware for physics experiments and not expect to get some shit for it. But anyway, though, so it turns out that if we were to vibrate the things at a lower level, say 1400 hertz, and then it was going to pop off and blow up at 19,000 hertz. Vibrating it for half a second at 1400 hertz and then hitting it with the 19,000 hertz causes it to blow up faster than if you just hit it with the 19,000 hertz. And it does so by half or better of the time. So being in motion, even at a much lower level, causes the reaction to happen that much faster. This has led to some interesting ideas on porting or venting entropic fields within the ray gun itself. So in essence, what we're going to attempt to do, the next jump up so successfully I can cause an irreversible action. I can also magnify the entropic fields as a result of that action within the gun itself. And I can polarize the fields. And through lots of insulation, because I'm not concentrating on that at the moment, so I'm just using very crude approaches, but through lots of very specific insulation, I think I'm capturing maybe as much as 80% of the entropic field and shooting it in a unidirectional fashion out of the end of my box. Now, it's probable that we need to do this in a way of multiple frequencies in order to get the best possible combination. But I can't afford, or I don't have the time to have many different teams trying different combinations and so on. And I don't have the ability to craft the software to do the modeling at the moment to run it conceptually that way. However, the idea has arisen that ports cut through the side of the graphite tube, little ports drilled in at oblique angles, leading to ports that come out of the sides of the steel box, which is a different polarity than the tungsten rod, is causing the irreducible act to begin to come out into the chamber and get magnified before the primary electron burst of 1 to 1,000,000, and it's just click and we're done. I mean, we just got a very crude switch on the batteries, and we just want to pop it off. And so basically you just make a connection and a spark, and then that's as much duration as we get on our electron gun, but it could be 1,000,000 electrons for all I know. In any event, though, this has been the most successful. So I've been able to actually magnify the effect by having this pre-vibrational state going within the resonating chamber, magnification chamber, whatever we want to call it, of the ray gun. And that's caused some level of pickup, maybe 80% more in entropic field volume coming out of the end that we're able to measure. Bear in mind, our measurements are quite crude because we're not really even sure what the nature of the field itself is and how our electronic devices should be reacting to it. But there is demonstrably something there that causes problems with little seedlings that we're using as our canary in the coal mine kind of thing, right? And so we know we're doing something because seedlings along the side of the box have no problem. Those that are getting blasted by the stuff coming out, they got real problems. In any event, though, so it's been kind of fascinating. Then I got to wrap this up, but then I had to shut down because the contractor had to come on in and gut the office to get rid of all the old crap, and then it's taken us, a month plus to get to the stage of the insulation being put back in, and now I have to live without it for another couple of weeks as we get the place sealed up. Then I can start putting all of the gear in there, which will take another couple of weeks, and then I can get back to this. So I was kind of thinking, well, this is sort of report up to where we're at the moment. Now I've got to go on now at this point and do work in the greenhouse and monitor temporal markers from the software and a few other things. So I'm not going to be getting back to this for maybe, I don't know, maybe a month or 6 weeks. Fascinating, though. Fascinating. If we can figure out a way to just simply get the resonance of the lattice work around it, then you can cause that lattice work to vibrate, and that shifts the one point. And if you can shift it past a certain point, you get molecular instability, which manifests in some very interesting ways. So sorry about the disruptions and the screwing up and putting it on mute and all of that. I'm going to have to go and get some chow at the moment. And thank you ever so much for coming and listening to this. And hopefully it hasn't been too boring about all of this. Oh, yeah, and shout out to the Nadia in Jamaica. Hi, Heidi. How are you doing? Yes, I know I owe Jenny a talk, too. I've got to get in contact with her and do that. So anyway, guys. We'll all say hi to Nadia as I go and figure out when I'm going to have her lunch here. But I'm going to use one of those wine glasses and put some of Bix Weir's father's wine in it. He makes just an excellent Pinot Noir. And sort of veg out and then get on to my regular chores. Bye, guys.